The students were dealing with structure basicity relationship. Structure basicity relationship of amines. So in that, first one was the alkyl amines versus ammonia. Now let us write a reaction where an alkylamine is there and it is donating a proton or donating the electrons to the incoming proton of the acid. So so what happens here is the electron releasing nature of the alkyl group pushes the electrons towards nitrogen and makes available the unshared pair of electrons available for the incoming proton. Therefore there is a plus I effect going on here. So the electron releasing nature of the alkyl group pushes the electron towards nitrogen and makes available the unshared pair of electrons on nitrogen for bonding with the proton. Therefore the resultant is a substituted ammonium ion. But if you see ammonia, you get the ammonium ion, but there is no alkyl group here. Therefore, alkylamines are more reactive or are stronger bases compared to ammonia. Moreover, this substituted ammonium ion that is formed gets stabilized due to the positive charge that gets dispersed due to the plus I effect of this alkyl group. Therefore, due to the dispersal of the positive charge because of the plus I effect, this substituted ammonium ion gets stabilized. That makes alkylamines more basic than ammonia. Therefore, you can imply that more the number of electron releasing groups in that amine, more powerful will be the amine, isn't it? Or it will be more basic in nature. Therefore, if you compare primary with the tertiary, the secondary, so here there is only one donor group or alkyl group. Here there are two, here there are three. Therefore, the tertiary amine will be more basic compared to secondary amine, and secondary amine will be more basic compared to the primary amine. But this is in gaseous state only. In gaseous state, you see that the trend is tertiary more basic compared to secondary more basic compared to the primary. When it comes to aqueous solutions, then the basicity of an amine not only depends upon the electron releasing nature of the alkyl group, or that is the plus I effect, it also depends upon solvation. Therefore, greater the size, lesser will be the solvation. Therefore, if you compare the three, what will happen? This size is smaller compared to this size, and this size is smaller compared to this size. So the whole trend that you observe gaseous state, as far as the basicity of the amines is concerned, gets reversed here. Here, tertiary is more bulkier compared to secondary, and secondary is more bulkier compared to primary. So the trend here, as far as basicity is concerned, is primary greater than secondary, and this is greater than tertiary. Okay, because in aqueous solution, it is not only the electron releasing ability or nature of the alkyl group, basicity also depends upon solvation, and solvation depends upon the size. So as size increases, solvation decreases. Therefore, here the trend is primary will be more basic compared to secondary. Secondary will be more basic compared to tertiary. Having said that, there is one more thing that you should know. What is the nature of this R group? Because R group that is there can be a simpler group like the methyl group, or it can be a bulkier group like the ethyl group. If the group is smaller or less bulkier, then what will happen? There will be less steric hindrance for hydrogen bond formation. But if it is bulkier, if it is bulkier, there will be steric hindrance for formation of the hydrogen bond. Therefore, that also plays an important part as far as the basic nature of amine goes. Therefore, you can conclude that the basicity of amines actually depends upon a subtle interplay of three things. First one, the plus I effect. The plus I effect is the inductive effect. Second one is the solvation effect, and the third one is the steric hindrance effect. If there is steric hindrance, again the order of basicity will change. Okay. Therefore, again it depends upon what is the nature of R. R can be a methyl group or R can be an ethyl group. If it is methyl group, which is bulkier, the order of basicity is like this. So C2H5 twice NH greater than C2H5 3 times N, and this is greater than C2H5 NH2, and this is greater than ammonia. So if it is methyl group as R, that means if it is bulkier, so secondary amine is more basic compared to tertiary, and tertiary amine is more basic compared to the primary, and primary is more basic compared to ammonia. But if this group is methyl group, and if it is methyl group, then again it is CH3 twice NH greater than your primary CH3 NH2, and this is greater than CH3 3 times N, and this is greater than ammonia. So see, the order goes on changing. So in gaseous state, it is always, it depends upon how many R groups are there. So tertiary greater than secondary, secondary greater than primary. In aqueous solution, then it depends upon two factors, the plus I effect as well as solvation effect. Therefore, the trend change. It should be primary followed by secondary followed by tertiary. Again, it depends upon now the steric hindrance. Therefore, what is the nature of R? If R is a simpler group, then steric hindrance is less. If R is a bulkier group, steric hindrance is more for formation of the hydrogen bond or hydrogen bonding. Therefore, this is the order if ethyl group is present. It means bulkier group is present, and this is the order if a simpler non-bulkier group is present. Therefore, you have to see the basicity of amines in terms of three things as far as if you want to relate that in terms of whether the amine is in gaseous state or whether the are checking the basicity in the aqueous solution, and third, basicity you can check depending upon what is the nature of R. Okay. So this is the alkylamines versus ammonia. So whatever it is, alkylamines are more basic compared to ammonia. Next is the aryl amines versus ammonia. So if I write an aryl amine like the primary aromatic amine like aniline, in case of aryl amines, the nitrogen atom of the group is directly attached to the ring, and therefore this pair of electrons on nitrogen is in conjugation with the unshared pair of electrons on nitrogen is in conjugation with the ring benzene ring. Therefore, you will get a series of resonating structures. Right, and this goes here, this goes here. You get one more structure. Okay, so you can clearly see that the unshared pair of electrons, since nitrogen is directly attached to the benzene ring, the unshared pair of electrons on nitrogen are in conjugation with the benzene ring, and you get a series of resonating structures. Moreover, what will happen now? Therefore, we will see that nitrogen is devoid of those electrons. So they are not available for sharing with the incoming proton. So this will make the aryl amine less basic compared to ammonia. Alkylamines are more basic because that pair of electrons is easily available. Why? There is an alkyl group which donates, or it has an electron releasing nature. So it pushes the electron towards nitrogen, and nitrogen can make available the unshared pair of electrons to the incoming proton. But here what happens in aryl amines? The unshared pair of electrons are in conjugation with the benzene ring, and therefore these are unavailable for sharing with the incoming proton. Therefore, these aryl amines are less basic compared to ammonia. Moreover, the aniline ion that is formed, it has two resonating structures. Okay, you know, more the number of resonating structures, more is the stability. Therefore, this aniline ion that is formed, okay, since it has only two resonating structures compared to the resonating structure of the aryl amine, you see that this is more stable compared to this. Okay, so this makes aryl amine less basic compared to ammonia. So alkylamines are always more basic to ammonia, aryl amines are less basic to ammonia. to the third property, that is acylation reaction. So what is acylation? Addition of the acyl group or addition of C double bond O dash CH3 group is called as acylation. So you can take amines and react them with acid chlorides, anything that has the acyl group. For example, acid chlorides. So what are these? These are R dash C double bond O dash Cl. Acid chlorides you can use, or anhydrides like R dash C or twice O, or you can use esters R dash C dash O dash R, right? So you can react amines with either acid chloride, anhydrides, as well as esters, where you can do the addition of the acyl group. So that reaction is called as acylation reaction. So let's try and see some reactions. So we can take C2H5 and H2 and react it with acid chlorides like CH3 dash CO dash Cl. So here, if you want, I can write this as dash H dash H. Okay, so this I can remove with this Cl. So I'll get HCl and I can write this here. So if I remove this, what will I get? I get C2H5, one H is gone, so I get NH dash CO dash CH3. So what is this? N-ethyl ethanamide. So this is addition of COCH3 group or R dash C double bond O group. This reaction is called as acylation. Similarly, we can use a secondary amine if you want. So C2H5 dash N dash H dash C2H5. So diethylamine you can use with CH3 dash CO dash Cl. So what will happen? Again, this H will go away with this Cl and this will come and join here. So you get C2H5 dash N dash C2H5 dash C double bond O dash CH3. So NN diethyl ethanamide will get. Okay. NN diethyl ethanamide. Okay. Let's try one reaction with aniline C6H5 NH2 plus CH3 dash C double bond O dash CH3 dash C double bond O dash O. This is acetic anhydride. So when you do that, you can break the bond here. One half you can give, H you can give here. So what do you get? You get C6H5 NH dash C double bond O dash CH3 plus CH3 COH. Okay, so we can write it this in another fashion, like for example, NH2 plus CH3 CO twice O will give you dash NHCO CH3 plus CH3 COH. What is this? This is one and the same, right? So what is this? Acylation. So this reaction is called as acylation reaction or acetylation also you can write, where amine is made to react with either an acid chloride or an anhydride or an ester. Okay, where the addition of acyl group takes place. Okay. Next we'll go into one more important reaction called as the Carbylamine reaction. Okay. Now what is this? This is whenever you take primary aliphatic or aromatic amines and react them with chloroform in presence of ethanolic KOH, then they give very foul smelling compounds called as the isocyanides or isonitrites, or simply we call them as carbylamines. Okay, so this reaction is also the test for primary aliphatic or aromatic amines. Now we should also remember that secondary and tertiary amines do not give this test. Okay, they don't form this or they don't give this reaction. Only primary aliphatic as well as aromatic amines will give you this carbylamine test. So what we have to do, we have to take an amine, react that with chloroform CH2Cl3 in presence of ethanolic KOH. So 3 times KOH. So what is formed? 6. What is formed? You get a foul smelling compound called as isonitrite. So how to write that? R-NC plus you will get 3 times KCl3 plus 3 times water. This compound is called as isocyanide, or it is also called as isonitrite. So R-CN is nitrite. This is R-NC, isonitrite, N triple bond C. This is isonitrite. It is a very foul smelling compound. Okay. So as I told you, this is given by the primary amines. Therefore, it becomes the test for primary amines, that is carbylamine test. So amine plus chloroform in presence of ethanolic KOH gives you the isocyanide, and that is called as the carbylamine test. Next is test with a reaction with nitrous acid. So nitrous acid is HNO2. So this has to be prepared in situ. Okay, by mixing a mineral acid like HCl with sodium nitrite. Okay, so normally we mix HCl plus sodium nitrite to get the acid called as nitrous acid. Now the behavior of aliphatic primary amines and the primary aromatic amines differs. Okay, so what happens is the compound, the disodium salt that is derived when nitrous acid reacts with primary aliphatic amines is unstable, whereas the compound that is formed, that is disodium salt, that is formed when aromatic primary amine reacts with nitrous acid is more stable. Therefore, you have two reactions now. One reaction is how aliphatic primary amine reacts with nitrous acid, and the second one is how the aromatic primary amine reacts with nitrous acid. So let's see with aliphatic primary amine. So if I take R dash NH2, react that with HNO2. So this, as I told you, is prepared by the reaction of HCl plus NaNO2. Refrigerated temperature is 0 to 1 degrees. So I told you, you get an intermediate, right? A compound, and disodium salt is formed. It's not an intermediate, sorry. The disodium salt is formed into plus, okay, Cl minus. Now this is unstable. This is unstable. Therefore, on addition of water, it breaks down, okay, and forms alcohol plus nitrogen is released, plus you will get HCl. Okay, so this is what will happen. So the disodium salt that is formed when an aliphatic primary amine reacts with nitrous acid being unstable breaks down to give you alcohol releasing nitrogen. So this is how aliphatic primary amine reacts with nitrous acid. Okay, so there is one more reaction which I will take up in the next class, that is how aromatic primary amine will react with nitrous acid.